Hi, Steve here again. Did you have fun counting those squares? How many squares did you find? So I'm going to work through the answer for you and show you a way of calculating the answer by using mathematics. Bye now. So here's the answer to the question I asked you before. How many squares did you find in the grid? So here was the grid, and here we can see it's a grid made up of 4 squares along by 4 squares down. So we can put these into sizes of square and count them as we go. So for a square of 1 side by 1 side, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 squares which are each 1 by 1. Now let's see if we can find any larger squares. What about those squares which are 2 by 2? How many of those are there? So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 squares consisting of 2 squares by 2 squares. Can you see the pattern that we're going to move to now? That will be 3 squares by 3 squares. How many of those are there? Well, here we can count 1, 2, 3, 4. So in total there are 4 squares, each made up of 3 smaller squares by 3 smaller squares. Now, can you see what's left? It's the actual grid, made up of 4 squares by 4 squares. How many of those are there? That's a nice easy one. Just 1. So if we add up the total of 1 by 1, 2 by 2, 3 by 3 and 4 by 4, we should get 30 squares. So the correct answer that we should have had was 30 squares. Wasn't that fun? Now what you can do is make an even larger grid and see how many squares there would be in that larger grid. So have fun and use the same method as I've done to get a total count. Bye now. I've seen something interesting here. Have you? Any number multiplied by itself is said to be squared. Now let's look at our 4 by 4 grid again. We had 1 times 1, which is 1 squared, 2 times 2, that's 2 squared, 3 times 3, that's 3 squared, 4 times 4, that's 4 squared. Let's find the result of those squared numbers. 1 squared, well that's 1, 2 squared, that's 4, 3 squared, that's 9, and 4 squared is 16. So let's add all those results up, and guess what? It comes to 30 again. Now that's the result that we had as our answer. So that's got me thinking, what if our grid was bigger? What if instead of 4 squares by 4 squares, it was 5 squared by 5 squares? What result will we have then for the number of squares? Well, 5 times 5, that's 5 squared, that equals 25. So the amount of squares we would have in a 5 by 5 grid would be the result of all those squared numbers added together. Well, that's 55. So there is the answer to a 5 by 5 grid. Now that's got me thinking again. I think we can solve the number of squares in any size of grid, like a chessboard. So let's have a look. The formula, and let's call n the number of squares along the rows and column of a grid, rather like our 4 by 4 or our 5 by 5 grid, gives us this formula. So n times n plus 1 times 2n plus 1 all divided by 6. Now that sounds a little awkward with n's all over the place, so let's replace the n with our 4. So here we can see how we apply the formula to give us an answer. So we've replaced all the n's with a 4. So now we have 4 times 4 plus 1 times 2 times 4 plus 1 divided by 6. So we do a bit more calculation, and this is equal to 4 times 5 times 8 plus 1 divided by 6. And a bit more calculation gives us 4 times 5 times 9 divided by 6. And this is equal to 180 divided by 6, giving us a grand total of 30. Now that's the answer to the number of squares in our 4 by 4 grid. So let's see if we can apply the same formula to a 5 by 5 grid. And do you remember the answer that we had? 55. So let's apply our formula using 5 instead of n. 5 times 5 plus 1 times 2 times 5 plus 1 divided by 6. That's equal to 5 times 6 times 10 plus 1 divided by 6. That's equal to 5 times 6 times 11 divided by 6, which is equal to 330 divided by 6, and the answer is 55. So here we've got a very useful formula for applying this to any grid that's square, and as long as the number of squares are the same along the rows and columns, like a chessboard, we'll be able to calculate, not count. Now that's a way of applying maths to a simple puzzle. Have fun with that and go and amaze your friends. Bye now.